We continue our discussion of adding and subtracting radical expressions in this video. What makes this a little bit different and a little bit more difficult is that we're going to have fractions, and so we have to go back and remember how to rationalize denominators, plus we have to remember how to add fractions, which means find common denominators. So again, I have a process. It's not a rule, but I think it will help you out. So the first step we're going to do is simplify any radicals. Square root of 3, square root of 3, can't simplify. Rationalize all denominators. Hopefully you remember what that means. Rationalize means get rid of the radicals in the denominator. So this is a radical in the denominator. How do we rationalize that? What do I need to multiply by to get rid of that square root of 3? Another square root of 3. So this becomes 4 square root of 3 over just 3. So now this problem is 4 square root of 3 over 3 minus 7 square root of 3 over 1. Now we have to find the least common denominator between 3 and 1. And of course it's 3. So this one's going to stay over 3. I need to multiply this by 3. So 3 times 7 is 21. Keep the square root of 3 over 3. What I've just done is I've rewritten all the terms with that least common denominator of a 3. I did that a little fast, so let's just go back. I rationalized the denominator, got to here, found a common denominator, got to here. Now let's see what kind of like terms we can combine. Fractions. They have to have the same denominator. I keep the denominator. And I collect, if any, like terms across the top. They both have the same radical, which means they are like terms, so I keep the square root of 3, and then I do 4 minus 21, which is a negative 17. I know that looks scary, but it's really not that bad. Let's look at a few more examples. Alright, so in example number 2, we're going to simplify those radicals. 6 is just 2 times 3, so I can't take out anything. But 24 is 4 times 6, which is 2 times 2, 2 times 3. Remember square root, we're looking for a pair. So I have 5 over the square root of 6 plus 2 times the square root of 6. I'm going to go ahead and put that over 1 since I'm working with fractions. Then I want to rationalize all the denominators, so I have to take care of that one. I'm going to come up here. 5 over the square root of 6, multiply by another square root of 6, and I have this. So this problem becomes 5 square root of 6 over 6 plus 2 square root of 6 over 1. Then I need to find the LCD between 6 and 1, which is 6. And I need to rewrite each term with that LCD. So this is already 6, so we keep that numerator. This one I need to multiply times 6, and I want to multiply outside that radical. So that's 12 times the square root of 6. And then I need to combine like terms. Fraction, keep the denominator. And then if there's any like terms on top, collect those. They're the same radical, so keep the radical. Add those coefficients. So this process combines a lot. Rationalizing, finding common denominators, combining like terms. That's a lot to remember. We've got 2 more examples. So in problem number 3, you don't see square roots. You see cube roots. Remember, we need to have 3 of a kind to take anything outside that radical. So can we simplify? Not that one, but that one. Let's see, 72. I think about 8 times 9. 2 times 2 times 2, 3 times 3. So I have 3 of a kind here, but not there. So this is 2 over the cube root of 3 minus 2 times the cube root of 9, and again I'm going to put that over 1. Then I'm going to rationalize the denominator. So I'm going to have 2 over the cube root of 3. What do I need to multiply by? Remember, 3 of a kind. So I need 2 more 3's. So that's 2 times the cube root of 9. And now I have 3 of a kind, which is just 3. So I'm going to replace that with my rationalized form, which is 2 times the cube root of 9 over 3 minus 2 times the cube root of 9 over 1. Now what's the least common denominator? Of course it's 3. So I keep this one. I need to multiply this times 3 outside the radical. So that's 6 times the cube root of 9. Done that. Next step, combine like terms. So keep the denominator, and then like terms, those are like because the radicals are the same, so I keep that radical. Can't simplify it. Square root of 9, yes. Cube root of 9, no, because it's only 2 3's, not 3. Then 2 minus 6 is negative 4. It's really not that hard. Let's do one last example, and oh my, what an example it is. The good news is that we're back to square roots. The bad news is that there's 3 of them. Alright, so what was that first step? Simplify. I can't simplify. Second step, rationalize. So first of all, let's write this as the square root of 2 over the square root of 3 plus 5 square root of 6 over 1 minus the square root of 3 over the square root of 2. So we want to rationalize those, which means I need to get rid of those radicals in the denominator. Okay, so let's take that one at a time. I need to multiply by that another square root of 3. So that's the square root of 6 over just 3. Now let's do this one. Square root of 3 over the square root of 2. Almost the same thing, it's just with 2's and not 3's, right? Okay, so this problem becomes the square root of 6 over 3 plus 5 square root of 6 over 1 minus, right, because there was a minus, the square root of 6 over 2. The good news is they're all the same radical, the square root of 6. The bad news is they don't have the same denominator. So we need to find that LCD between 3, 1, and 2. And hopefully you know that is 6. So I need to multiply this one times 2, this one times 6, and this one times 3. So I have 2 square root of 6. 6 times 5 is 30 square root of 6. And this is 3 square root of 6. So they all have the same denominator, so keep that denominator. They all have the same radical, keep that radical, and then add or subtract those coefficients. So that's 32 minus 3 is 29. So they look kind of scary, but they're really not that bad.